An engine misfire is a critical automotive problem that every driver should understand. When one or more cylinders in your engine fail to properly ignite the air-fuel mixture, it creates a cascade of performance issues. In a properly functioning engine, each cylinder fires in sequence, creating smooth power delivery. But when a misfire occurs, one or more cylinders fail to ignite, disrupting this smooth operation. When misfires occur, you'll experience several immediate effects: loss of power and acceleration, rough idling with engine vibration, increased harmful emissions, and significantly reduced fuel economy. Engine misfires fall into four main categories. First, ignition system issues, which account for about 40% of all misfires. These include worn spark plugs and faulty ignition coils. Second, fuel system problems cause about 35% of misfires. These include clogged fuel injectors, fuel pump failures, and contaminated fuel affecting proper combustion. Third, mechanical failures account for 20% of misfires. These include low compression from worn engine components, timing issues, and vacuum leaks that disrupt the air-fuel mixture. Finally, sensor-related issues cause about 5% of misfires. Faulty sensors like the mass airflow sensor or oxygen sensor can provide incorrect data to the engine computer, leading to improper fuel delivery. Recognizing misfire symptoms early can save you from costly repairs. Watch for these key warning signs: rough idle with noticeable engine vibration, decreased acceleration and power, unusual engine sounds, and most importantly, the check engine light on your dashboard. The first step in diagnosing engine misfires is identifying when they occur. Note whether the misfire happens during idle, acceleration, or under load conditions. Next, connect an OBD2 scanner to read diagnostic trouble codes. Look for P codes in the P0300 to P0312 series, which specifically indicate misfire conditions in different cylinders. Inspect the spark plugs for wear, carbon buildup, or damage. Check the electrode gap, which should typically be between 0.28 and 0.060 inches, depending on your vehicle's specifications. Test the ignition coils by swapping them between cylinders to isolate faulty units. Use a multimeter to check primary and secondary resistance values according to manufacturer specifications. Check the fuel system by testing fuel pressure, which typically ranges from 30 to 80 psi depending on the system. Inspect fuel injectors for clogs or leaks that could cause uneven fuel delivery. Perform a compression test to identify mechanical issues. Normal compression should be between 120 and 180 psi, with less than 10% variation between cylinders. Modern vehicles feature advanced diagnostic technologies, including AI-enhanced OBD systems that can predict misfires before they occur, and real-time cylinder pressure monitoring for instant feedback on engine performance. For gasoline direct injection engines, carbon buildup on intake valves is a common cause of misfires. Walnut shell blasting every 60,000 miles can prevent this issue and maintain optimal engine performance.